Let's learn about division algorithm for polynomials. Dividend, the number which is being divided. Divisor, the number that is being divided into the dividend. Quotient, the result obtained when numbers or expressions are divided. Remainder, the part that is left over when the divisor no longer goes into the dividend a whole number of times. Division algorithm: if f of x and g of x are any two polynomials with g of x not equal to 0, then we can always find polynomials q of x and r of x such that f of x is equal to q of x, g of x plus r of x, where r of x is equal to 0 or degree r of x is less than degree g of x. If r of x is equal to 0, then polynomial g of x is a factor of polynomial f of x. Long division. If the divisor has more than one term, perform long division. You do the same steps with polynomial division as with integers. Let's do two problems, one with integers you know how to do and one with polynomials, and copy the steps. Let's observe the following. Dividing polynomials. Divide a polynomial by a monomial. Let's observe the following. Dividing polynomials. Divide a polynomial by a monomial. Let's observe the following. Long division. Divide the first term of the numerator by the first term of the denominator. Distribute your quotient by the entire polynomial in the denominator. Distribute a negative by through your product. Dividing polynomials. Dividing a polynomial by a polynomial, long division. Let's observe the following. Dividing polynomials. Dividing a polynomial by a polynomial, long division. Let's observe the following. Polynomial division. Let's observe the following. Let's observe the following examples. Long divide. Let's observe the following. Division of polynomials. Division of polynomials is similar to a division sum using numbers. Consider the division 10 divided by 2 is equal to 5. Consider the division x squared plus x divided by x plus 1. Let's observe the following example. When the division is not exact, there will be a remainder. Let's observe the following example. Let's understand the relationship between zeros and coefficients of a polynomial. If p of x is a polynomial in x and if k is any real number, then the value obtained by replacing x by k in p of x is called the value of p of x at x is equal to k and is denoted by p of k. Let's observe the given example. Generally, a number k is a zero of a polynomial p of x if p of k is equal to 0. In general, if k is a zero of p of x is equal to ax plus b, then so the zero of the linear polynomial ax plus b is thus the zero of a linear polynomial is related to its coefficient. Let's observe the following example. Let us take a quadratic polynomial p of x is equal to 2x squared minus 8x plus 6. Now we factorize quadratic polynomials by splitting the middle term. So we split the middle term minus 8x as a sum of two terms whose product is 6x 2x squared. Let's observe the following. Let's understand through the following example how to find the zeros of the polynomials and how to verify the relationship between the zeros and coefficients of the polynomials. Find the zeros of the polynomial x squared minus 3 and verify the relationship between the zeros and the coefficients. Let's observe the given example. Zeros of polynomial functions. In the complex number system, every nth degree polynomial has precisely n zeros. Fundamental theorem of algebra. If f of x is a polynomial of degree n, where n is greater than 0, then f has at least one zero in the complex number system. Linear factorization theorem. If f of x is a polynomial of degree n, where n is greater than 0, then f has precisely n linear factors. F of x is equal to an of x minus c1, x minus c2 to x minus cn, where c1, c2 to cn are complex numbers. Rational zero test. To use the rational zero test, you should list all rational numbers whose numerators are factors of the constant term and whose denominators are factors of the leading coefficient. Possible rational zeros is equal to factors of constant term by factors of leading coefficient. Once you have all the possible zeros, test them using substitution or synthetic division to see if they work and indeed are a zero of the function. Also, use a graph to help determine zeros to test. It only tests for rational numbers. Using the rational zero theorem. List all possible rational zeros of f of x is equal to 15x cubed plus 14x squared minus 3x minus 2. The constant term is minus 2 and the leading coefficient is 15. Possible rational zeros is equal to factors of the constant term minus 2 by factors of the leading coefficient 15. There are 16 possible rational zeros. The actual solution set to f of x is equal to 15x cubed plus 14x squared minus 3x minus 2 is equal to 0 is minus 1 by 3, 2 by 5, which contains 3 of the 16 possible solutions. Roots and zeros of polynomials 2. Finding the roots, zeros of polynomials, degree 3 or higher. Graph the polynomial to find your first zero, root. Use synthetic division to find a smaller polynomial. If the polynomial is not a quadratic, follow the two steps above using the smaller polynomial until you get a quadratic. Factor or use the quadratic formula to find your remaining zeros' roots. Find all the zeros of each polynomial function. Let's observe the following. First, graph the equation to find the first zero. From looking at the graph, you can see that there is a zero at -2. Second, use the zero you found from the graph and do synthetic division to find a smaller polynomial. The new smaller polynomial is third, factor or use the quadratic formula to find the remaining zeros. This quadratic can be factored into 5x minus 3, 2x minus 1. Therefore, the zeros to the problem 10x cubed plus 9x squared minus 19x plus 6 are x is equal to -2, 3 by 5, 1 by 2. Writing a polynomial given the zeros. To write a polynomial, you must write the zeros out in factored form. Then you multiply the factors together to get your polynomial. Factored form: x minus 0, x minus 0. If p is a polynomial function and a plus bi is a root, then a minus bi is also a root. If p is a polynomial function and a plus root under b is a root, then a minus root under b is also a root. The zeros of a third degree polynomial are 2, multiplicity 2 and minus 5. Write a polynomial. First, write the zeros in factored form. Second, multiply the factors out to find your polynomial. First, FOIL or box two of the factors. Second, box your answer from above with your remaining factors to get your polynomial. Let's consider an example. Find the zeros of the polynomials f of x is equal to 4 root 3x squared plus 5x minus 2 root 3 and verify the relationship between the zeros and its coefficients. Let's observe the given solution. Steps for finding the zeros given a solution. Find a polynomial with a given solution, foil or box. Use long division to divide your polynomial you found in step 1 with your polynomial from the problem. Factor or use the quadratic formula on the answer you found from long division. Write all of your answers out. Find roots, zeros of a polynomial. If the known root is imaginary, we can use the complex conjugates theorem. Find all the roots of fx is equal to x cubed minus 5x squared minus 7x plus 51. If one root is 4 minus I, because of the complex conjugate theorem, we know that another root must be 4 plus I. If one root is 4 minus I, then one factor is x minus 4 minus I and multiply these factors. Let's observe the following. If the product of the two non-real factors is x squared minus 8x plus 17 is then the third factor that gives us the real root is the quotient of p of x divided by x squared minus 8x plus 17. The third root is x is equal to minus 3. So all of the zeros are 4 minus I, 4 plus I and minus 3. Descartes' rule of signs. If f of x is equal to a n x to the power n plus a n minus 1x to the power n minus 1 plus till a2 x squared plus a1x plus a1x plus a0 be a polynomial with real coefficients and a0 is not equal to 0. The number of positive real zeros of f is either equal to the number of variations in sign of f of x or less than that number by an even integer. The number of negative real zeros of f is either equal to the number of variations in sign of f of minus x or less than that number by an even integer. Variation in sign is equal to two consecutive coefficients have opposite signs. Using Descartes' rule of signs. Determine the possible number of positive and negative real zeros of f of x is equal to x cubed plus 2x squared plus 5x plus 4. To find possibilities for positive real zeros, count the number of sign changes in the equation for f of x. Because all the terms are positive, there are no variations in sign. Thus, there are no positive real zeros. To find possibilities for negative real zeros, count the number of sign changes in the equation for f of minus x. We obtain this equation by replacing x with minus x in the given function. If f of x is equal to x cubed plus 2x squared plus 5x plus 4, this is the given polynomial function. Replace x with minus x. Let's observe the following. Now count the sign changes. There are three variations in sign. Number of negative real zeros of f is either equal to 3 or is less than this number by an even integer. This means that there are either 3 negative real zeros or 3 minus 2 is equal to 1 negative real zero. Upper and lower bound rules. Let f of x be a polynomial with real coefficients and a positive leading coefficient. Suppose f of x is divided by x minus c using synthetic division. If c is greater than 0 and each number in the last row is either positive or 0, c is an upper bound for the real zeros of f. If c is less than 0 and the numbers in the last row are alternately positive and negative, 0 entries count as positive or negative, c is a lower bound for the real zeros of f. Let's understand the relationship between zeros and coefficients of a cubic polynomial. Let alpha, beta and gamma be the zeros of a cubic polynomial ax cubed plus bx squared plus cx plus d. A is not equal to 0. Then by factor theorem, therefore, where k is any non-zero real number, comparing the coefficients of x cubed, x squared, x and constant term on both sides we get Let's understand through the following example how to find a cubic polynomial if the values of sum of zeros, sum of the product of its zeros taken two at a time, and product of its zeros are given. Find a cubic polynomial with the sum of zeros, sum of product of its zeros taken two at a time, and product of its zeros as 2, -7 and -14 respectively. If alpha, beta and gamma are the zeros of the cubic polynomial f of x, then let's observe the following. Let's understand the relationship between zeros and coefficients of a polynomial. If alpha and beta are the zeros of the quadratic polynomial, p of x is equal to ax squared plus bx plus c, a not equal to 0. Then we know that x minus alpha and x minus beta are the factors of p of x. Let's observe the following. Let's understand through the following example how to find the value of an expression involving zeros of a quadratic polynomial by using the relationship between zeros and coefficients of polynomial. Let's observe the following example. Let's understand the relationship between zeros and coefficients of a polynomial. If alpha and beta are the zeros of the quadratic polynomial, let's see some miscellaneous applications of division algorithm. Let's observe the following example. Let's observe the following example. What must be subtracted from 8x to the power 4 plus 14x cubed minus 2x square plus 7x minus 8 so that the resulting polynomial is exactly divisible by 4x square plus 3x minus 2? We know that dividend is equal to quotient into divisor plus remainder. Dividend minus remainder is equal to quotient into divisor. Clearly, RHS of the above result is divisible by the divisor. Therefore, LHS is also divisible by the divisor. Thus, if we subtract remainder from the dividend, then it will be exactly divisible by the divisor. Let's observe the following. Let's observe the following example.